the fatty acid go during the breaking down of triglyceride?
Well, it is actually undergoes via beta-oxidation.
What does that mean?
Beta-oxidation process will start when the fatty acid is fully oxidized into the acetyl-CoA. Then we are going to TCA cycle. From there, it will yield the NADH and NADH2, which are going to electron transport chain and yield ATP. First, we need to add active fatty acid. In order to activate, we need to add fatty acetyl-CoA group at the end making of fatty acetyl-CoA. This reaction is catalyzed by fatty acetyl-CoA synthetase. Just looking at the name synthetase, we can get a clue that we need ATP to make this reaction happen. This is also called thiokinase, which kinase means using ATP, and thio is going to represent CoH group. The next step in beta-oxidation is to transfer the fatty acetyl-CoA from the cytosol into the mitochondria. However, it needs a little helper, and this little helper is going to be carnitine. Carnitine is going to be put onto acetyl-CoA by the action of carnitine acetyltransferase, which is in the outer membrane of the mitochondria. The carnitine will be added to this fatty acetyl-CoA, which will then transport it into the matrix through these transporter proteins. From there, it will remove all of the carnitine through the action of CAT2, which is continuing to transfer H2, and the removed carnitine will be resettled back out and used to add more. The matrix where beta-oxidation will take place, and our fatty acid will be converted back into its fatty acetyl-CoA structure. We now undergo beta-oxidation in the matrix of mitochondria. We're going to start with carbon fatty acid that has 16 carbons, and our first step is going to be the oxidation for alpha and beta carbons from carbonyl group of fatty acetyl-CoA structure. So, carbons will lose 2 hydrogens and are going to be gained by FAD to produce FADH2 by using the enzyme of acetyl-CoA dehydrogenase. We know that FADH2 is going to electron transport chain and yield 2 ATP. Our second step is going to be hydration. We're going to add water molecule across the double bond at the alpha and beta carbons, and here we can see the OH and the H is at the alpha and beta carbon of fatty acetyl-CoA by using the enzyme of enol-CoA hydratase. So, after we hydrated in the previous step, now we're going to oxidize it again. That means we're going to lose 2 hydrogens from the alpha and beta carbons. And those hydrogens are going to be added to NAD+, and it reduced into NADH by the enzyme of hydroxyacyl dehydrogenase. After our oxidation, now we're going to undergo dialysis. That means we're going to add a CoH, which is a coenzyme to break apart the acetyl-CoA and have a remaining fatty acetyl-CoA by the enzyme of thiolase. We know that acetyl-CoA can go into the TCA cycle and yield just like in glycolysis yield energy. Our remaining fatty acetyl-CoA we're going to break down into acetyl-CoA. How much energy do we get from beta-oxidation? Well, we have been using of the 16 carbon fatty acid. How many acetyl-CoA do we get per 16 carbons? Well, acetyl-CoA has 2 carbons, then we just divide by 16 and it gives us 8 acetyl-CoA. How many rounds of oxidation do we need undergo to get those 8 acetyl-CoA? The answer is 7 rounds because the last step is just going to be breaking off those 2 final acetyl-CoA. So we don't have to undergo beta-oxidation for that final acetyl-CoA. Hence, NADH and FADH2 has the similar round of oxidation, which is 7. How many ATPs do we get? Well, we know from the TCA cycle that is 1 acetyl-CoA is going to give us 12 ATPs. So, 8 acetyl-CoA will be multiplied by 12 ATP to get 96 ATP. 1 NADH is equivalent to 3 ATP. So, 7 NADH will be multiplied by 3 to get 21 ATP. 1 FADH2 is equivalent to 2 ATP. So, 7 FADH2 will be multiplied by 2 to get 14 ATP. The total ATP is 131. But when we recall from the first step of fatty acid activation, we use 2 ATP for activated and made acetyl-CoA. So, we must subtract by 2 to get 129 ATP.